Here's the text with proper punctuation. Insect juice is keeping the examination world in tension after the red supermonster stood out in later years with outrageous vacillations and splendor. Some specialists believe that the explosive destruction of the heavenly mammoth is approaching, but now the right shoulder of Orion is creating a ruckus once again. On the one hand, there is the theory that Betelgeuse is turning much faster than it should because it once consumed another star. On the other hand, there is the suspicion that the heavenly monster is not alone. However, assuming that Betelgeuse is actually a binary star, why hasn't the companion star been discovered yet? And how would its presence directly lead to the formation of a major mystery in our imagination? The sun often represents the ultimate in the universe, which makes sense. In theory, our Earth would fit into our powerful mother star around 1.3 million times. And although the Sun, with a diameter of almost 1.4 million kilometers, can confidently be described as impressive, we shouldn't forget that there are far larger celestial bodies out there that would transform our central star into a faint dust particle. A quick reality check brings us back to rational terms in regard to astronomical facts. We realize that Betelgeuse bests the Sun in every possible way. Located around 650 light-years from us in the Orion constellation, this red supermonster's diameter is about 1,000 times larger than that of the Sun. This huge difference in size is also reflected in terms of radiance. In fact, Betelgeuse shines a whopping 100,000 times brighter in visible light than our source of warmth and life. Well, quite surprisingly, even in space research, the principle seems to apply that exceptions confirm the rule. A few years ago, Betelgeuse presented specialists with a gigantic mystery when it drastically lost brightness within a few weeks. In fact, the stellar dimming was so pronounced that it could even be seen with the naked eye in the night sky. Occasional brightness fluctuations are quite normal for Betelgeuse, but in this case, it dimmed much faster and more intensely than usual. A quick aside, the cosmic unit of magnitude indicates the apparent brightness of a celestial body. The smaller the magnitude value, the brighter the object appears to us. Normally, Betelgeuse, with an average luminosity of 0.3 to 0.4 magnitudes, is one of the 6th or 7th brightest stars in the entire sky. However, in December 2019, it dimmed to 1.1289 magnitudes, dropping to 21st place in the brightness rankings. Is Betelgeuse going to become a supernova? Consequently, experts had to search for explanations for this unexpected development. Since Betelgeuse, as a red supergiant, is approaching the end of its stellar life, the suspicion briefly arose that its brightness drop was connected to an imminent supernova. When it is not experiencing a mysterious dimming, Betelgeuse shines 100,000 times brighter than the Sun. However, when it says goodbye in a violent explosion, researchers expect it to experience a 16,000-fold increase in its current luminosity. In this case, Betelgeuse would reach an apparent brightness of -9.5 to -11.5 magnitudes. Some experts believe that the celestial body will then appear as bright as the full moon and should even be easily visible during the day. However, when exactly we can expect this brilliant spectacle is an entirely different question. In fact, most experts have now abandoned the assumption that the supernova will occur in the near future. What was once interpreted as a harbinger of a grand spectacle turned out to be a massive plasma eruption during follow-up observations. This, in turn, produced a no less significant dust cloud, which obscured the star by almost 2/3 from our natural view. As previously mentioned, Betelgeuse has reached the final stages of its life cycle and regularly loses large amounts of stellar material. This is transported to the surface by convection currents from the interior and ejected. At the same time, Betelgeuse also experiences 400-day cycles of expansion and contraction. Experts estimate that it was the combination of strong convection and expansion that caused the plasma eruption to be several times more intense than usual. And if we draw the comparison to the Sun again, we see that Betelgeuse is also ahead in this regard. The rate of mass loss during this event was about 30 times higher than for our Sun. Essentially, the ejected plasma likely cooled in space and eventually condensed into a massive dust cloud. Since this happened to be in the view between Earth and the red supergiant, it appeared to us as a massive veil that visibly darkened the star. Now, the rotation puzzle: has Betelgeuse consumed another star? Betelgeuse wouldn't be Betelgeuse if it didn't have a few more mysteries in store for astronomers. For instance, images taken by the coupled radio telescopes of the ALMA observatory a few months ago suggested that it is rotating at an unusual speed for a red supergiant. The rotational speed is more than 5 kilometers per second, which is about 150 times faster than expected for a star of its spectral class. Betelgeuse completely defies the cosmic rule here. Stars typically slow down as they expand. In this context, Jingsma from the Max Planck Institute for Astronomy in Garching, Bavaria, points out that Betelgeuse is actually the only known red supergiant believed to rotate so quickly. Specifically, this rotational speed is attributed to the bipolar structure of the surface, where one half shows a blue shift and the other a red shift of several kilometers per second. But what explanations do astronomers have for this remarkable rotational behavior? The first theory is that Betelgeuse is a cosmic predator. In other words, when it expanded into a supergiant about 100,000 years ago, it may have swallowed a companion star, similar to the Sun. In this scenario, the ingestion of so much mass caused the consumed star to transfer its angular momentum to Betelgeuse's outer shell, thereby accelerating its rotation. While this hypothesis was tested in a computer model, tangible evidence has also been gathered. Images taken by the Herschel Space Telescope several years ago showed that two zones of ejected stellar material lie dormant on one side of the supergiant. These shell-like structures were initially interpreted as precursors to the upcoming supernova explosion. However, they are located exactly at the distance where they would be expected after a stellar cannibalism event. There are other possible explanations, though. Ma's research team points out that the surface of the star is adorned with massive bubbles of rising and falling plasma, which can cover a significant part of its visible outer shell. The rapid movement of these plasma bubbles can also produce the aforementioned red and blue shifts of the radio emissions. In short, it is possible that Betelgeuse isn't rotating too fast after all, but rather that it's creating a sort of optical illusion. If a large convection bubble, or a group of them, is moving toward the observer while another is moving away, even a non-rotating star can appear to rotate very quickly. A recent analysis of ALMA data combined with an astrophysical model showed that this explanation is far from implausible. In fact, according to Ma, there is a 90% chance that the patterns produced in the simulation will be misinterpreted as high rotation rates. This is mainly due to the low resolution of the ALMA images, which distorts the actual characteristics of the movements on the stellar surface. So, at present, it is impossible to say with absolute certainty how fast Betelgeuse truly rotates and how likely the scenario of the consumed star is. But what we can say is that evidence is mounting that the red supergiant isn't alone after all. Does Betelgeuse have a companion star? As mentioned earlier, Betelgeuse's brightness and surface pulse in a cycle of about 400 days. Well, technically, the red supergiant still hasn't fully recovered from the massive plasma eruption of 2019. The resonations of the eruption continue to cause rapid oscillations in its interior, while the surface is still vibrating like an oversized jelly. According to astronomers, it will take several years before the star returns to its normal rhythm. However, despite its 400-day pulse, Betelgeuse also exhibits a secondary, longer brightness fluctuation that occurs over a cycle of 2,170 days, or almost 6 years. The reasons for these long-period fluctuations remained unclear for a long time. To finally address this, Jared Goldberg and his colleagues from the New York-based Flatiron Institute recently dedicated themselves to reanalyzing all the observational data on Betelgeuse. The new research indeed revealed a number of surprising irregularities. These begin with the fact that the 6-year cycle in the star's light curve follows a different rhythm than the subtle 400-day pulses. Additionally, the long-period fluctuations are offset against the rhythmic pulse. However, the researchers couldn't identify any accompanying phenomena that would be associated with causes such as rotational sequences, magnetic field effects, or convection currents. Ultimately, the researchers concluded that there is only one possible explanation for the long-period oscillations without major flaws: the presence of a smaller companion star. Otherwise, the strange 6-year fluctuations would reflect the orbits of the companion star. When the stellar companion is behind Betelgeuse as seen from Earth, the secondary period is at its lowest brightness. However, when the companion is near Betelgeuse, the luminosities of the two celestial bodies combine, and the brightness reaches its maximum. At the same time, the companion star could also act as a natural dust shifter, influencing the distribution of dust clouds and thus playing an additional role in Betelgeuse's brightness changes. So far, so possible. But why hasn't a companion star been detected yet? Well, the answer is simple: Betelgeuse's gigantic dimensions. After all, we know that its radius is larger than that of the entire orbit of Jupiter in our solar system.